Back in 2018, I bought my first 3D printer, and at first I absolutely loved this machine. It was great, 3D printing was something new to me, and to be able to draw something and then 3D print it was really exciting. But it didn't take long, and I actually started to hate a 3D printer. I think the main reason was purely because of the amount of time that it took to print anything. It just seemed like forever. And you'd be into like a 10-hour print, and 9 hours into that print it would come loose or the nozzle would clog or something, and then you'd have to start again. So it was very, very frustrating. And then also the noise that it made. Most of the time you'd run the printer through the night, or if it was during the day and you were home, the noise that it made was just unbearable. It's just constant noise. You couldn't have it within a few meters of yourself, well, in the next room or whatever. It's just too noisy. But things have changed, and I've got myself a new 3D printer, and I'm absolutely in love with 3D printing again, just purely because of how much time it saves you. It really speeds things up, and it really allows you to visualize what you're doing, and I find that is a huge time saver. So with today's video, it's a classic example of if I didn't 3D print the part and I didn't have a look at it and I sent it straight off for laser cutting, I would have wasted at least another week of time. Let me show you what I'm talking about. So the next thing I need to do is put this cross member in here, and that is going to hold a engine mount that's going to come off over here and bolt onto this cross member. So what I needed to do was to draw a plate that would come down here like this, where this cross member would bolt onto. So what I did was a little bit of YouTube CAD, computer aided design, cardboard aided design, and I drew up my template, which is going to sit something like that. And I just made sure that it cleared the front valance, and then I wanted to measure up where these holes were and just the size of this, and this is where the mistake came in, because I didn't have enough space to draw on this side of the piece of paper. I flipped it over and I wrote down a few dimensions, and the key dimension here is this 4mm and this 16mm. So I took this to the computer and I drew it up and I 3D printed it. And this is what I ended up with. And I mean, technically it's actually right, because there's my cardboard template. The dimensions are correct, but when I go to fit it, it doesn't fit because I've done the flange the wrong way. So I could put it to this side, but now you can see how those holes are off. So it's not really the end of the world. I could just slot it and I could make it work. But I mean, really, if you're going to spend that time on having it laser cut, you want it to be right. So I then did an iteration, and I printed this one, and this one goes this side, and it fits perfectly. So classic example, it would have taken me, I would have waited a week for these parts to arrive, then to realize that they're wrong, then to redo it, and then wait another week for them to arrive. So 2 weeks. So you've probably saved a week. So that's pretty much why I really enjoy 3D printing the parts that I'm going to have laser cut, so I can check where everything goes. And here's a further time saver, because what I'm going to do now is I'm just going to bolt this in here, and this allows me to hold this cross member in place so that I can 3D scan where this cross member is in relation to the engine. So if I had to wait for that plate to come a week, then bolt this up, then order these plates, that's another week. If I made a mistake, it would have taken me a month just to put this in. Well, close to. So yeah, let me show you how I put the engine mount together. So there I've got the cross member just balancing in place, and it's mounted accurately with a piece of cardboard it wouldn't have that same accuracy. How would you hold that tube in here? How would you get this cross member to be accurate to that piece? And you wouldn't be able to do it until you had that piece in your hand. So now I could rotate the engine to get it to the right position, and then I could scan in just this section here, and then I could place the engine mount again in CAD, maneuver it around until I was happy with it, and then draw in the plates to make up the engine mount. So let's move over to the computer and I'll show you how I did that.
So this was a very quick, easy scan. All that I had to do was capture that cross-member tube. Then I could draw in all the brackets. I can put in one bolt hole with a slug over there, and that was it.
So here are the parts for the front engine mount, which again I could 3D print just to check the fitment, and that is how it's going to fit there. So I had this laser cut here because I need to bend this little flange over. I didn't get them to bend it because they can't bend such a small flange on such a thick piece of steel. So all that I'm going to do now is just lightly put a grind in these three places and just lightly bend it over and then weld it up on the back side. But there we go, left and right. And then these are the bits for the engine mount. And this piece here bolts onto the bottom over here, and that's what makes this piece removable, so they can come apart. So I'll just have 3 M8 bolts. So for some other reason, I never put in any adjustment on this engine mount. So I think what I'm going to do is cut these 2 flanges here off and put in a flange that has a slot here so that I can rotate the engine up and down in that slot. Didn't think of that. That engine mount's got adjustment, that engine mount's got an adjustment, and I think this one and the one that's going to go at the back also need an adjustment. So the last thing to do to finish this little job off is to put in this bolt, this tube, something like that. So I just need to cut it over here somewhere.
Okay, drawing up this tunnel, I didn't get it right on the first iteration. I drew quite a few different tunnels, different sections, and you can see this one, I've still got the construction line showing up. It was just way too big. But finally I got onto a design that I liked. If I show it here, inserted in, you can see there's a massive gap here. So when I marked on where to cut, I had to leave enough material so that it could be folded out, pop riveted into place, and then later on welded. So as I say, it wasn't the first time that I got it right. I put on a few flanges there so I could offer it up to the back and again rivet that together. So from here, what I did was, that's what the tunnel ended up looking like. Just to give you some idea of dimensions, from the top to the bottom is 200 millimeters, and the width is 170. So it's not a massive tunnel, but it fits really well. So from here, I then drew a section, which I then 3D printed. So with having this 3D print, it gave me a lot of confidence that I could have a piece in my hand and that I could manipulate it and put it over the tunnel and see, how does it fit? Can it be stretched a little bit? It didn't have to be exactly 170 millimeters wide. It could be manipulated to 180 millimeters or even bigger. So that gave me a lot more confidence. So the time came that I just had to man up, draw a line, and start cutting. Gotta say, it was very intimidating. But fortunately, I had a really good mate of mine, D, to come and give me a hand. And it made the job so much easier that if I was on my own, it would have taken me just hours and hours. And having D there with me, it only took us a few hours because he could offer up the piece, we could test it, he could pull it out, try it, and this was repeated over and over and over.
With the tunnel now trimmed to size, it's ready to be welded into place. But before I do that, I want to get the steering rack into its place. So I need to move the steering rack down by approximately 25 millimeters, but I also need to move it closer to the firewall as much as possible. I can move back probably about 10 millimeters. And the reason for this is to miss the coupling here, which goes onto the drive shaft. I'll be fabricating up a plate that fits in here that'll have two M8 bolts, which will then provide the two mounts to hold the steering rack back into the correct place. I'll also have to trim this little seam here so that this rubber boot can miss that, and I'll have to do it obviously on both sides. And then once that's done, the steering rack is in place. So now that the tunnel has been pop riveted into place, I can start doing the welding to hold it in, and then I'll probably have to remove the pop rivets again because they're going to corrode with the carbon, but I'll deal with that later. So the next job is to put the drive shaft in. I think I'm going to leave that for where we are now, and then I'll get on to marking up the drive shaft. It's going to need to be shortened a little bit, but first engine back in, steering rack back in, and then we can start playing around with the drive shaft and we'll see where we go from there. I think next on the list is going to probably be brakes and steering column, I should say. So yeah, like, subscribe. If you got any questions, please leave a comment, and we'll see you in the next one.